homework. Page 479, right, okay, I gave you 1, 2, no, was that it? Yeah, 1, 2, 3, 5, 7 and 8, was that it? Did I record yesterday's class? I think I did I? Yeah. Did I not put it up? Yeah, you did, I think. Yeah, it should be up there. Right, okay, if I didn't put it up, it's only because I forgot. Right, okay. Right, anyone need any bit of number 1 done? Any bit of number 2 done? Any bit of number 3 done? Part 3. So part 3 is 1 over 8 to the power of x is equal to the square root of 2. Okay, so this is 8, this is 2, so I'm going to write everything as with a base of 2. So 2 to the power of something. So changing 8 to 2 to the power of something, 8 is 2 to the power of 3. So that's 2 to the power of 3 all to the power of x equals, over this side, square root of 2 can be written as 2 to the power of a half. Okay, that's something you learn, that square root is to the power of a half. That isn't going to jump into your head, you need to remember that. Okay, that's 1 over 2 to the power, raising a power to a power, you just multiply, so that's just 3x equals 2 to the power of a half. Now I have 1 upstairs and 1 downstairs, so I need to bring the downstairs up or the upstairs down, either or. So I'll bring the downstairs up. Yes, sorry.
What does it say inside the bracket beside the 2?
Beside 2 to the power of 3.
How did you get 3?
2 by 2 by 2 is 8. 2 by 2 is 4 by 2 is 8.
Yeah.
Okay, and there's no button on the calculator for that, you just need fingers. Right, and take off your shoes and socks and your toes as well, right, if you run out of fingers. Right, okay, this is downstairs, this is upstairs, so I'm going to bring this up, and it's 2 to the power of minus 3x when it comes up. Okay, I can ignore the 1 that's already there, because it's just multiplied by 1, which is the same thing. Right, equals 2 to the power of a half. Once I have a 2 to the power of equals a 2 to the power of, I cross off the 2 to the power of, and I get minus 3 is equal to a half. Then I'm going to divide each side by minus 3, and I end up with x is equal to minus 1/6. Yeah? Good? It's alright? Yes. What did I what?
What did you divide?
I divided each side by minus 3 because it was a minus 3 stuck to the x.
Yeah.
So minus 3 is cancelled there, and on my calculator a half divided by minus 3 is minus 1/6. Is that okay? Right, everyone okay? Right, that was any other part of number 3?
Number 4.
Part 4, right, okay, so 3 part 4. Right, is 7 to the power of x equals 1 over the cubed root of 7. Okay, so that's 7 to the power of x is equal to 1 all over, the cubed root is 7 to the power of 1/3. Again, that's a fact you need to remember. Right, so upstairs, downstairs, they need to be on the same level. So I'll leave this 7 to the power of x. Right, I'm going to bring this upstairs and make it 7 to the power of minus 1/3. I have 7 to the power of equals to 7 to the power of, so I can knock it off, and I get x is equal to minus 1/3. We okay with that? Yes.
How come you only changed it to minus 1 then? Why isn't it minus 7?
You only change the power. Okay, the rule is when you move it, you change the sign of the power, the base stays the same.
Yeah.
Is that right? So that's the rule. Okay, right, are we good? Right, okay, that's 3. Did I give you 4 or no? 5? Am I doing 5? Anyone? No? 6 I did. 7, okay, yeah, 7 I said I hadn't an example done of number 7, but I said I'd give you a go. Were you able to do it? Will I do it? Yeah, okay, so number 7 says it's basically the substitution method, so it's 3 to the power of 2x, right, minus 12 multiplied by 3 to the power of x plus 27 equals 0.
Excuse me, please, reminder to teachers to attendance on the portal. Could Veronica Chomo and Zahir Kakar come to reception at the bell? Also Heather O'Connell and a chap here in reception was found in Patrick One classroom this morning. Can be claimed here. Thank you.
Right, so it tells you in the question, let y equal 3 to the power of x. So that means everywhere you see a 3 to the power of x, right, you replace it with a y. So before I start, this 3 to the power of 2x, that's the same as 3 to the power of x all to the power of 2, isn't it? Because raising a power to a power, you multiply. X multiplied by 2 is 2x. Is that alright? Minus 12 times 3 to the power of x plus 27. So that's the only change I made there. Instead of writing 3 to the power of 2x, I wrote that's 3 to the power of x all to be squared. Okay, so I'm now replacing that with a y. So everywhere I see a 3 to the power of x, I'm calling it y. Okay, minus here, instead of 12 times 3 to the power of x, is 12y plus 27 equals 0. Factorize and let each bracket equal 0. Two sets of brackets. Factors of 27 to give me 12 are 3 9s, and that's a minus and a minus. Okay, equals 0. Then you let each bracket equal 0, so you get y minus 9 equals 0, and you get y minus 3 equals 0. So that means y equals 9, y equals 3. Okay, I'm not finished though, because they asked me what x was, not what y was. Okay, so I have to, because I substituted to solve, I now have to substitute back. Okay, so my original substitution was everywhere I saw a 3 to the power of x, I put a y. Now I'm going the other way. Anywhere I see a y, I'm changing back to 3 to the power of x. So 3 to the power of x equals 9, and 3 to the power of x equals 3. So write everything as a power of 3. So 3 to the power of x equals 9 is 3 to the power of 2. Knock off the 3's and you get x equals 2. Am I gone off? No, I'm okay. And over here I have 3 to the power of x. Sorry, I don't need to do that. I just 3 on its own is 3 to the power of 1. Knock off the 3's and you get x equals 1. We good?
Yeah.
Right, number 8 is the exact same. Will I do it?
Yeah.
Second example? Yeah? Can I move it up? Going. On. Okay, number 8 is the exact same except they don't tell you what to substitute. Okay, so we have 2 to the power of 2x minus 3 times 2 to the power of x minus 4 equals 0. Okay, so I'm going to change that to 2 to the power of x all to be squared minus 3 times 2 to the power of x minus 4 equals 0. How did I know to do that? Because this is a 2 to the power of x here. So, right, I want everything in terms of 2 to the power of x. So then I replace y is equal to 2 to the power of x. So everywhere I see a y, I'm putting in a 2 to the power of x. So that's y squared minus 3y minus 4 equals 0. Right, so that's 2 sets of brackets. Y and y, 4 and 1, a minus and a plus. So then you let each bracket equal to 0. So y is equal to 4 and y is equal to minus 1. Is that okay? Right, so now I have to substitute back. So y was 2 to the power of x, so 2 to the power of x equals 4. 2 to the power of x equals minus 1. 2 to the power of nothing will ever give you a negative number, so that's not a possible answer. Right? 2 to the power of 2 to the power of anything will never give you a negative number. You can't have a negative answer to a power. Right? Okay, so here we get 2 to the power of x equals 2 to the power of 2. Knock off the 2's and you get x equals 2. Is that right? Are we good? That was it, yeah? Right, okay.
Is the answer x equals 2?
The answer is x equals 2. Yeah. There's only one answer because the second one isn't a valid solution, as in 2 to the power of something can never give you a negative number. Right? Okay. Are we good? I have it on freeze, I didn't have to wait for you anyway. Right, okay, so what we're doing now is we're doing graphs of exponential functions. So graphs of exponential functions, it's still on freeze, isn't it? Right, okay. So what we're going to be doing here is we're going to be graphing exponential functions. Exponential functions are a number to the power of x, right? Okay, as in x is going to be in the power, right? It could be 2 to the power of 2x, it could be whatever, okay? The x is going to be in the power, right? Okay, so we're just going to, I'm going to draw this one, and then on the same graph I'm going to put some extra ones, and we're going to notice a pattern, okay? So basically I'm drawing it between -3 and 3. So yeah, sorry, I'll move myself over a small bit and that would be better. Right, okay, are we okay?
What does it say before the -3?
In the domain,
Oh.
-3 is less than or equal to x is less than or equal to 3. Okay, so that means I'm going to put in a -3. So x, I'm going to put in a -3, I'm going to put in a -2, I'm going to put in a 0, I'm going to put in 0, 1, 2, and 3, and I'm going to get the points. Okay, I'm going to do these out manually, but you do them on a calculator. Okay, so if I go 2 to the power of x, remember the function is 2 to the power of x. So when I put in that, that's 2 to the power of -3 into the calculator with that, and I'll get 1/8. Okay, so that's my first point, -3, 1/8. Okay, yes, yeah. Okay, then I put in a 2 to the power of -2 into the calculator with that, and I'll get 1/4. So I put in a -2 and I got out 1/4. Okay, then I go 2 to the power of -1, so that's 1/2. So I put in a -1 and I got out 1/2. 2 to the power of 0 is 1. Anything to the power of 0 is 1. So I put in a 0, got out a 1. 2 to the power of 1 is 2. So I put in a 1, got out a 2. 2 to the power of 2, sorry, there's no bracket there, is 4. So I put in a 2 and I got out a 4. And 2 to the power of 3 is 8. So I put in a 3 and I got out an 8. Did I? I did, yeah. Is that alright? Okay, so now I'm going to graph those points. Okay. Okay, can I... Okay, are you ready? Can I take that away? Right, okay. -1. I'm in double minus 2, minus 3, and 1, 2, and 3. Okay, so my first point was across to minus 3 up to 1/8. Okay, so 1/8. Then minus 2 1/4, minus 1 1/2, 0 1 1 4. Sorry, that's not 1 4. That's 1 4. No, it's 1 2, isn't it? Sorry, 1 2 2 4 and 3 8. Okay, right. So then your graph, it goes like this. Oh, for God's sake, it's supposed to be nice and curvy. Okay, so that's y is equal to 2 to the power of x. There's your graph. Right, okay. I already said that 2 to the power of anything can never be negative. So it'll never go below the x-axis. As I go back this way, it's going to get nearer and nearer to the x-axis, right? But it's never going to hit the x-axis. Like if you did 2 to the power of minus 100, if you did x is minus 100, 2 to the power minus 100 is a teensy tiny fraction, but it's not 0, but it's not below 0 either. So as you go towards the negative numbers, you're never going to get to 0, right? As you go positive, it gets really big really fast. Okay, the growth of COVID grows exponentially, as in it gets really big really fast. If you were to graph the numbers of cases of COVID, right, they get really big really fast. Okay, worldwide, it's an exponential curve, as in it started off with 1 case, right? Okay, so and as time went on, it was really big really fast. Okay, so the COVID curve is actually an exponential graph. Okay, right. Right, so exponential curves, right, points about them. Exponential curves, right, always point at x equals 0. Right, always, wait now, I'll go. Exponential curves always, I'll dumb it down, as in I won't use fancy language. Always cut the x-axis, or cut the y-axis at 1. As x tends towards minus infinity, as x gets bigger that way towards the minus numbers, the graph gets nearer to the x-axis, but never gets there. Right, so the curve gets nearer and nearer, the fraction gets teenier and teenier, so it gets nearer and nearer to the x-axis, but it never actually gets to the x-axis, right? So as it goes to infinity that way, it'll be nearer and nearer, it'll be nearer and nearer to the x-axis, but it'll never actually hit the x-axis. Is that alright? Okay, so there's a fancy word for that. Does anyone remember, did you hear it? The x-axis, so this implies the x-axis is an asymptote, it's called. Have you ever heard that word before? Asymptote. So an asymptote is it's just a line that the graph gets nearer and nearer to but never reaches. So it's an asymptote, it's called. So we say the x-axis is an asymptote, just in case you ever come across that word. Right, that's what it means. Okay? Right, okay, yeah. Right, okay. Also, girls, if I was to graph y equals 3 to the power of x, right? Okay, so y equals 3 to the power of x. This is a bit rough now, as in this is a bit wide. Okay, so y equals 3 to the power of x. It's going to be below the black line, right? Okay, look where y equals 3 to the power of x is. Right, it gets tighter to the y-axis. Okay, if I had y equals 10 to the power of x, right, it would be below here, underneath it, right? Okay, it's y equals 10 to the power of x. It's nearer again. So if I had y equals 100, yes,
Sorry, for the second sentence, it is as x.
10 to minus infinity.
Oh,
Right, okay, that's it's supposed to be the infinity symbol. It's an 8 sideways, right? So as x heads that way is what I'm trying to say, right? Okay, y equals 10 to the power of x is tighter to the x-axis, or to the y-axis, right? Y equals 100 to the power of x will be in here somewhere. Y equals 1000 to the power of x will be nearer again, right? Okay, so as the base number gets bigger, it gets tighter to the y-axis. Does that make sense? Right, they all still cross at 1 though. Every single, what you call it, exponential graph crosses at 1. Because remember, it doesn't matter what the thing is, a to the power of 0. If it was a to the power of x, a to the power of 0, so it doesn't matter what the base is, because a to the power of 0 is always 1, isn't it? So that's why all of them cross at 1. Is that okay? So they all cross at 1, yes.
Is it like with the x-axis, as in can it never cross over the y-axis again? Like
Yeah.
no matter how
Yeah, it'll get nearer and nearer, but it won't ever come back over this side. Is that all right? Now these graphs here, right, on this side these are all y equals a to the power of x, where a is greater than 1, right? So a is greater than 1 means it's if a equals 1, it's just 1 to the power of x will be here. So this is a equals 1 is just a straight line. And then 2 to the power of x, 3 to the power of x, they all move up a bit. Is that alright? Okay, right. If a is less than 1, as in if the base is a fraction, right? If a is less than 1, it's the mirror image, right? Okay, or the axial symmetry in the y-axis, it'll be over here. So if y equals a half to the power of, so this is y equals a half to the power of x. Is that right? So if they're fractions, right, okay, it's over there, right? If it was 1/3 to the power of x, it would be the mirror image of the y equals 3 to the power of x. So this is y equals a half to the power of x.
Excuse me, Miss Healy will be doing an after-school Christmas baking class. It will be on a Wednesday. If you're interested, please go to the old kitchen at a 10:10 break tomorrow. Thank you.
And y equals a quarter to a 10 to the power of x or whatever. Okay, so if it's a fraction, if it's between 0 and 1, right, if the base is between 0 and 1, so if a is between 0 and 1, as in the base is a fraction between 0 and 1, it's actually over at this side and it's going the opposite direction, but it's still got the same shape. The x-axis is still an asymptote, right, as in it's heading for the x-axis, it's never getting there. Is that okay? Right, okay. Remember, a half to the power of x, you know that? I say that that's this graph here. Just, that would be 1 to the power of x over 2 to the power of x, wouldn't it? Roosevelt says 1 to the power of x, 1 to the power of any number is just 1. 1 by 1 by 1 by 1 by 1, doesn't matter how many you have, you just have 1. This would be 2 to the power of x. So I can write 1 over 2 to the power of x as what? 2 to the power of minus x. Okay, so you know the way I said a half to the power of x, another way of writing that would be 2 to the power minus x. 1/3 to the power of x, another way of writing that would be 3 to the power of minus x. Okay, just so you know, 2 to the power minus x, 3 to the power minus x are all these numbers, are all the fractions. Okay, it's just another way of writing the fractions. They all still cross a 1. The x-axis is still an asymptote, as in they're heading there, they never get there. they get, the bigger the number underneath the line, so the bigger the number underneath the line, in this case, the tighter it is to the y-axis. The bigger the number here at this side, the tighter it is to the y-axis. And one is, they're a mirror image of each other, right? Okay, is that okay? So if you were to fold along the y-axis, the mirror image of y equals 2 to the power of x would be y equals a half to the power of x, etc. So one's a mirror image of the other. Does that make sense? Are we all okay? Right. Anything else you need to know about exponential graphs? Just on, if I just graph here, so if I just say y equals 2 to the power of x, y equals 2 to the power of x, we'll cross at 1, they all cross at 1, yes? Right, okay, what if I had y equals 2 multiplied by 2 to the power of x? That's a multiply, the dot is a multiply. I'm not writing a multiply sign because I don't want you to think it's an x. So if I had 2 multiplied by 2 to the power of x, right? Okay, it would have the exact same graph, except it's going to move up. Everything's going to double, isn't it? So instead of having 0, 1, I'll have 0, 2. Instead of having 1, 2, I'll have 1, 4. So this would be the exact same shape. That is not the exact same shape. The exact same shape, except it would be moved up, right? And it would cross at 2. Equals 2 multiplied by 2 to the power of x. Right, okay. What about if I was to draw y equals 3 multiplied by 2 to the power of x? Where would that cross? Where would that cross the y-axis? If it was just 2 to the power of x, it would cross at 1, wouldn't it? If it was 2 by 2 to the power of x, it would cross at 2. If it was 3 multiplied by 2 to the power of x, it would cross at 3. If it was 100 times 2 to the power of x, where would it cross? At 100, okay? So they all cross at 1 unless it's multiplied by something, right? And then it'll cross at whatever it's multiplied by. Got it? Right, okay. Wait, now if I see. Right, we might just look together at question 1 on page 483 if you have it. If you don't, I have it up here. Okay. Right, matches each of the following, right, exponential functions with the graphs. Okay, so look, what do I know about this one? It's on the left hand side and it's coming down. So what do I know about the base? So it's something to the power of x, but what do I know about the something? It's a fraction, isn't it? It's between 0 and 1. Agreed? If it's bigger than 1, it's going to have this shape, right? Because it's less than 1, it has this shape. So which one of these is less than 1 to the power of x? Be part 2, isn't it? Because it's 1/10. 0.1 is 1/10 to the power of x. Would you agree? Okay, so that's definitely number 2, right? Okay, this one crosses at 1. This one crosses at a half, probably, and this one crosses at 1. Okay, so the fact that this one crosses at a half, that means there's something multiplied in the middle at the start, and it must be a half. So which one is this? Number 4. And this one, we're finally left with a 2 to the power of x and a 10 to the power of x. Which one is 10 to the power of x? B or D? D. Because the bigger the number, the tighter it is to the x-axis. Is that okay? These are just, you know, that's as much as you'll be expected to know about them. Is that alright? Okay, now, I'm going to look at number 2 here now, and I'm going to do it as my example, right, but I'm not writing it out because it's really long. Okay, so we'll just read it, right, okay, and then we'll, sometimes they like to put a nice story to it, okay, right, so it's an exponential function, right, there's a story attached, big swing, right, okay, we're cutting to the chase, we're getting the equation, and we're filling it in or whatever we need to do to it, okay, so don't be put off by these stories because they're just, they love bacterial growth, by the way. I think this is a grasshopper plague. Lovely. Right. So So an entomologist monitoring a grasshopper plague notices that the area affected by the grasshopper is given by, here's our function, here's our exponential curve, right? 1000 by 2 to the power of 0.2 n, right? That's what that says, by the way. Right, okay. Why is that crooked? Because the thing is crooked. I don't think I straightened it. I think I made it worse. Right? Anyway, right, okay. So, where n is the number of weeks that have elapsed after the initial observation, right? Can I just tell you, when these stories, right, okay, they're always time, right? They're nearly always time. And at the start, it's like they're starting the clock. So at the start, what's the time always equal to? Zero. Right, they start the clock at 0, so they're counting weeks. Okay, but at the very start, the number of weeks was 0. Right, there might be minutes, seconds, hours in other questions. At the start, you know, they say initial, at the start, time is always 0. Right, so n here is 0 at the start. Right, so it starts with n equals 0 weeks, n equals 1 week, n equals 2 weeks, etc. Is that alright? Okay. N is the number of weeks that have elapsed after initial observation. Find the area originally affected. Right, the area originally affected. Right, and I might take this away and actually write this into your example copy. We'll put the answers, if you want to, just listen to me for a minute, and then we can do it in a minute, okay? And I'll be flipping over and back, and then I'll put it up so we can write it into your example copy. So don't write just yet, because you need to see what I'm doing. So example 1 is page 483, question 2. I'm definitely not writing it out because it's too long, okay? But they told me that the area as a function of n, so the brackets n just means, it's like f of x. Do you know the way we had f of x equals? Right, so the area equals 1000 multiplied by, and they use a multiply sign because they're using n here, 2 to the 0.2 n, right, and n is the number of weeks. Is that okay? Just be careful with that, because they love to give you these and they tell you n stands for the number of minutes or something, and then they'll give you a question in seconds, right? Or in this case, it says number of weeks and they might give you a question in years or something like that. So just make sure the units match, okay? Right. So it says find the area originally affected. So originally means at the very start. So what did I just say at the very start? What does n equal to at the very start? 0. Right? Okay. So the area as a function of n is equal to 1000 multiplied by 2 to the power of 0.2 times 0. So that would be 1000 multiplied by 2 to the power of 0. Here's where people go wrong. 2 to the power of 0 is 1. Okay, I'd be a rich woman if I got €1 for every time someone said 2 to the power of 0 was 0. Right, okay, and I'm not rich at all. Right, okay, so that's the area that originally affected was 1,000 hectares. You don't need a unit, it's an algebra question, they don't need units, but just, is that alright? So when they started this entomologist, he was, the very first day he started counting, there was 1,000 hectares affected by this grasshopper plague. Is that alright? Okay, right, number 2. So as I say, I'll put all this back up in a minute, right? Okay, so part 2 says find the area affected after 10 weeks and the area affected after 12 weeks. Okay, so I'm going to do A and B now. 10 weeks and 12 weeks, and it's okay because it's the number of weeks, right? Okay, so I'll give you a break now in one tick. We'll just finish this one. So part 2A was 10 weeks. So that would be 1,000 multiplied by 2 to the power of 0.2. It's zoomed in, right? Okay. Or by 10. 10 weeks, into the calculator with that and press equals. Right, B is 1,000, it was 12 weeks, wasn't it? Yeah, 2.2 times 12 weeks, into the calculator and press equals. Okay, you can have a 5-minute break and I'll be doing them in the calculator. Okay, so it is, sorry? Yeah. It's 14:27, I'll see you at 14:33. We'll assume this minute is gone.